Very good afternoon to all of you. We are back again with our course, that is project management. In the last class, we had seen for the block 2, unit 4, where it was discussed many of the aspects regarding project scope management. When we discussed about project scope management, we talked about scope encompasses the time, the cost as the basic impact which can affect a network, or we can say a project. Now, how can we know the time or estimate the time duration for completion of a project? For that, we use a certain analysis called as network analysis. It is having two type of techniques under it: the CPM, or in other words critical path method, and PERT, that is program evaluation and review technique, PERT. First we will start with CPM, then we shall move on to PERT and see what are the basic differences between the two techniques and how we can utilize these two to find out the duration of a project, and as well as what is the probability in completion of a project. So let us begin today's work. Now, what is that network analysis? First of all, we can say it is nothing but a framework for or to develop project schedules and for updating and control of projects. Now, it will help us to guide how project schedules can be made, or in other words, what are the expected duration of completion of various project activities individually, phase wise, and finally, what is the overall project schedule or the duration. And as we go on implementing the activities, we can see what was our estimated thing at the planning stage for completion of activities in terms of time, and what are the actual things done, so that we can update ourselves and we can take control measures. Are we lagging behind any of the activities in terms of time? If it is, how can we make up? Otherwise, the whole project schedule will become lagged, or it will have a time overrun. Now, we shall move on to how we can do the diagrams. Now, basically, we are focusing now on the CPM method, critical path method. In POT also, we'll use similar kind of diagrams, something called as the first or the most widely used or the simplest form of diagrams. It is called as AOA. So, what it is? Now, it is a mechanism to depict interdependencies of various activities used in a project. Now, what is interdependencies? For example, if I take the project of construction of a house, we can say that two activities, small activities, can be the skeletal structure, that means consisting of the pillars on which the roof will rest, the roof of the house will rest. Now, here we can say the roof activity can only be started after the completion of the pillars or the skeletal framework of the house, or the core skeletal framework for the house. So, In a project, there are many activities which are dependent on its previous activity. That means a activity can be started only if its previous or predecessor activity is completed. So we can depict through this AOA diagram. So as we said, it is the simplest is AOA diagram. What is that AOA diagram? Now AOA stands for activity on arrows. Now activities, we can say yes, it is a work that is being implemented in the project on arrows. Now, usually activities are shown as arrows on a network diagram. So, when you show activity on arrows in a network diagram, we call it AOA diagram. Now, we shall see some of the basics while using AOA diagrams, which can help us to create the network diagram. So at the beginning stage, we shall use some simple forms. As we become experts in this subject, when we work in some organization doing lots of projects, then we can use the computer programs which will be handling a large number of activities having various kind of interdependencies. So first is activity. Now what is an activity? Now any work that is going on in the project is called as activity. Now we have seen in WBS in the last class work breakdown structure that a total work can be broken down into small components. Now each small component will combine together to form the total. The example we took in the last class was a calculator. So here, if we take any project, we can break it down into small work components called as activities, and they will be shown as arrows because we are using the technique of AOA diagrams. Now how those arrows we can show in the network diagram. Now let me show you here. All of you can see it is a straight line arrow. This may not be straight here because I am doing a freehand diagram, but it should be a straight line arrow in this format. Now each activity is given a name, and usually we adapt English capital letters to represent the activities. Now here, suppose I say my activity is represented as A, or A depicts a particular activity like roof of the house. So in the network diagram, I am showing the arrow which is the work of constructing the roof of the house, and in the diagram the arrow will be marked on the top A, and below that suppose I write a number 21 days. What it means? Now the activity A that is depicting the roof of the house will take me 21 days to complete. Now here you can see the starting point, all of you can see, and here is the ending point of the roof. All of you can see here clearly the starting point and the ending point of the roof. Now, this is the representation of an activity in our network diagram. We can have many activities, we can represent it through English capital letters. Suppose somebody may ask if it is more than 26. We can go on for A subdenotation 1, A2, A3 or AA, AP, AC. Like this we can represent. Next, we move on to suppose activity A. This is our activity A that we already had. It was taking 21 days. Now, each activity has a starting point and a definite finishing point. Now all of you see clearly activity A, that is construction of the roof, is having one starting point that we call as starting event. So event marks whether an activity is started or it is completed. And usually in AOA diagram, we represent it through the numericals in a sequential manner. Suppose I say 1 and 2. So activity A has a tail event. This is the tail. And this is the head. Or you can say this is starting event and this is finishing event. So activity A has, or any activity will always have two events. One is starting or tail event. Second is the head or the finishing event. Now we can construct a diagram in the form of a chain like this. Suppose I do a simple event diagram like this. All of you can see here. Activities are A, B, C, D, E. And the events sequentially I can number as 1, 2, 3, 4, and 5. What is the starting point of the project? Now we can say this is the starting point of the project. When the project is completed, now when event 5 will occur. That means both event E and D are completed. When all the activities are completed, we can say the project is completed. Now, let us see what are the different kind of events we can have or activity interdependencies. First is simple events. Now, let me show you through a diagram. Suppose in the network, I have a particular these are the events 1, 2, 3. We We can have their duration below, but now only to represent it. Now, all of you or all of us, let us see B, activity B. How many predecessor or activities following behind it? Now, only one, that is A. Now, talk of A. Now, A is having only one successor, that is B. When such a thing happens, then we call it as simple event. Second, let us see what is a merge event. When two or more activities end up at a single event, suppose this is 4, this is 5, this is 6, this is event H, this is event G. Now, all of us, let us see event 6. We have two activities H and G which are terminating or being ended up at event 6, or in other words, activity I has two successors, predecessors, right? Now here two activities are merging in event 6. So this is called as merge events, right? Similarly, I can have another example, that is burst. What is that burst? Suppose I have this as H, this is 4, this is event 5. Now after event 5 is completed, two activities are beginning, that is finishing with event 6 and 7. This is I, this is J. Now all of us see, event 5 leads the way for a burst of events. That means two or more events, more activities are emerging from event 5. So this is called as burst event. Now, combined merge and burst events. What we mean by that? Let us see. Both merging that we saw in the second case here, and burst we saw here. How it will be looking like? Suppose this is 7, 8, 9, 10th event, 11th event. This is H, I, J, K. All of us see events 7 and 8, which are having activities H and I. They are merging at event 9, and event 9 is again bursting into activities J and K which are finishing at 10 and 11. So here we are having merging and here we are having burst. So here we are having burst and here you can see there merging. So both merging and bursting are happening together. Now another thing we use in network diagram is dummy activities. What is that? Let me show you. All of us see before E, who is the preceding activity? Na C. Before F, who is the preceding activity? D. Now suppose in this particular network, I will say that before F, both C and D will be there. Before F, both C and D will be there. Now what can I do? Can I draw another this activity like this as C? The answer is no. Suppose I draw another C. No, this becomes wrong because you cannot have same two activities in a project network diagram. So what we do there? Now, instead of doing that, let me erase that first. Just 1 second. Sorry. One second, please. You're having little trouble. Let me fix it first. Yes, now we are having the thing. How can I do it? Sorry for the trouble. As I was saying, before F, C and D will be there. what I do, I use a dotted line arrow and show it as small d. Dotted line arrow means a false activity which is pointing towards F. All of us see the arrowhead is moving towards F. So before F, C is coming towards F, D is coming towards F. But E, before E, only C is present. All of you can see it clearly. So this is dummy activity to show the interdependency. Now, information required for drawing network diagram. What information we require? First is a work breakdown structure. In the last unit 4, we had seen how a total work can be divided into its small components at various levels till we reach the final level. That is, the whole structure is called as work breakdown structure. Similarly, activity interdependencies. Just now we saw in the last slide the preceding activities, successors, the dummy activities, etc. Time estimates. Yes, I showed when we saw an particular activity. Below that, we write its duration, suppose 22 days. Then levels of network. Just like work breakdown structure, a project is suppose a house. You can have various kind of levels. This is plinth. This is civil works. This is, you can say, electrification. Then this is L1. This is L2. This is civil works make V for the rooms, the floors, etc., which we can take it as level 3. Now we can see clearly in our project, suppose for example, I have taken 3 levels in the network diagram. Now what is the lowest level? Now civil works for rooms, civil work for floors. So these are the smallest activities or the smallest segment of activities that we can have in our network. So each activity has to be taken care of so that we can move on to the final level or the top level, that is level 1, that is house. So these are the 4 information basically required to draw the network. Now here I am taking an example of a project. Now these all belong to the CPM method. CPM stands for critical path method. Another technique is there, that is PERT, P-E-R-T. I will say about that also. But here let us take the activities and let us see how the network diagram we can do here. When we are beginning the network diagram, all of us let us try to remember that we need a little bit of practice so that we get acquainted with the thing. What is the first thing we shall do? We shall do rough diagram. Secondly, we shall check all the relationship, precedence relationship. If it is okay with the given data set, or according to the project, then we can proceed to find out what are the final network diagram as well as the duration of the project. Now here you see three type of information is given. What are the basic activities required? What are its preceding activities? And the time in weeks that is required. So let us start to do it here. First, activity A. Now, activity A, this is event 1, this is event 2, and it takes 10 weeks. All right, B. It also do not has a preceding activity. All of you can see A or B is not having any kind of preceding activities. Here the events I am naming as 3 and 4, and it is taking 5 weeks. Now this is wrong. Why wrong? Now in a network diagram, we shall have a single beginning point and a single ending point. So what can I do here? What I will do here, I will put a single event here. From here, I will try to do A, and here it is B. Now, let me do it again. That is why I said we shall go for rough diagram. Let me erase it. All right. Yes, let me begin now. We are having activities A and B, which do not have any preceding activities. Yes, A and B do not have any preceding activities. Before C, A is there. Before D, A is there. That means after A is completed, we can say that C will be done and D will be done. Now before E, B is there. Now before E, B is there. This is my E. I have joined it here because I have tried it in rough first. Then F. It is C. Yes, rightly C. Before G, it is DE. F and G are merging at an event. Here also we are having a merge. Here we are having C and D as burst. Now we mark the events in a sequential manner. A takes 10 days, B takes 5 days, C takes 12 days, D 8, E is 4, F is 4, G is 3. All of you can see, before A no one is there, before B no one is there. Before C, A is there. We can cross verify ourselves. Before D, A is there. Yes. Before E, B is there. Yes. Before C, before F, C is there. Correct. Before G, both D and E are there. Correct. Once we get up to this stage, all of you see one starting point of the project and one ending point of the project. This should be maintained. This is the completion of the project. Now, what is the duration here? Now, how can I find out the duration? I'll try to locate what are the various paths that are there in the project. When I say path, start from the starting event, move on without lifting your pen or pencil or finger till the ending event. One is A, C and F. How much time it is taking? Not 10. For A, C is taking 12 plus 4, that is equal to 26 weeks. Now, another path can be A, D, G. A, D, G. How much time it is taking? A takes 10 days, D takes 8, G takes 3. So total is 21 weeks. Similarly, I can have another path, that is B, E and G, which is taking us 5 plus 4 plus 3, that is equal to 12 weeks. Now, we are having 3 different paths. When can I complete the project? Now, all of you keep in mind that in order that a project is completed, all paths should be completed. Path 1, path 2, path 3, all should be completed. Now, if I say path BEG is taking 12 weeks, that is the project completion time. Am I correct? The answer is no, because within that 12 weeks, the first path SCF will not be completed. So we can say the path with the longest duration is the duration of the project. It is the project duration, or it is called as critical path. Path with the longest duration is our critical path, and usually we show as double lined arrows in the network diagram so that one can clearly identify. Now, how shall we analyze the time? The same diagram we shall do again, but with a bigger circle. This was A, B, C, D, E, F, oh, after B, A, B, C, D, E, yes, E, F, and this was G. Now this was event 1, 2, 3, 4, 5, 6. What I do, I divide the lower portion into two parts of each event. Now the duration of the activities duration of the activities, right below that 10, 5, C was 12, D was 8, E was 4, F was 4, G was 3. And we saw the critical path was ACF in the last slide, and the project duration was 26 days. Now, for an event, any event I take, suppose event 4, this is my earliest starting time, this is my latest starting time for any event. right? So how can I find this? Now I use two kind of rules here: forward pass and backward pass, like in football. What is forward pass? Now start from the starting event, that is 1, and put 0 here as time. Now 0 plus 10 for next event, it is 0 plus 10, that is 10. This way it is 5. I go adding. 10 plus 12 is 22. 5 plus 4 is 9. Just stop here. And this way it is 9. And this way, because merging events, 10 plus 8, it is 18. When you are going by forward pass, take the highest. Out of 18 and 9, highest is 18. Similarly, here 22 plus 4, 26. Since it is merging, we shall see both the ways. 18 plus 3, it is 21. So I take the highest among the two, because two activities are merging here. So highest is 26. So now, while going backwards, I equate this as 26 and come back in the reverse way. 26 minus 4, that is 22. 26 minus 3, that is 23. 22 minus 12, that is 10. Wait here, because we are having two events coming back. 23 minus 18, it is 15. While coming back, take the lowest. So that is 10. 23 minus 4, that is 19. Again we are having two events coming back to the starting event. 10 minus 10, that is 0. Wait here please, 0. 5 minus 5, 0. Minimum of these two is 0. So now for each of the event, I am having earliest starting time and latest starting time. Now what I do? Activity A, what is the earliest starting time? Now it is 0. I put here 0. Earliest finishing time, suppose 4 and 6. From the diagram I take 6 is 26. Here it is F, having a duration of 4 weeks. This was 22 and this was 22 from the diagram. So this is earliest finishing time. This is latest finishing time of an activity. So now for F, earliest I can put is for A, it is 0. Earliest finishing time is 0. 10. Latest finishing time is 10. Latest starting time is 0. Similarly, I can go on filling up all the things by this calculation. All of us can do this. Now we try to check for slacks. What we do, this table which we have filled up, we shall take and we shall put the values here. Now we can have three different types of slacks: total slack, free slack, independent slack. Once I have got all this information, so my task will be easier. Total slack is equal to, immediately you can say LF, latest finishing time, minus earliest finishing time. So it is 10 minus 10, for here it is 0. Free slack, earliest starting time of J. J means next activity or succeeding activity. Now for activity A, succeeding activities are C as well as D. So there you can take the succeeding activities, earliest starting time of the succeeding activity, minus earliest finishing activity, earliest finishing time of that particular activity A. Similarly, while taking independent slack, you have to consider the succeeding activity, the earliest starting time, the latest finishing time for the preceding activity, and finally minus the duration of the activity. So here it is, J stands for succeeding activity, H stands for preceding activity of the activity for which you are calculating independent slack, minus its duration. Similarly, you can have time scaled networks. There arrows up till now we have seen are not represented in proportion to their durations, but here it will be shown as proportion in order of their durations. We draw the critical path first, followed by other paths. So it helps us to monitor and control the activities by comparing the actual and scheduled performance at any given point of time. Now up till now we have seen a technique called as critical path method, which was using a single time duration, and it was called as deterministic model because it was having a single time estimate. However, we know that a project is exposed to future uncertainties. We do not know whether we can complete the thing or the activity in a given time duration or not. So what happens in the future? We have three kind of time estimates: optimistic time, pessimistic, and most likely. Optimistic is everything will go for us. That means we can complete the activity faster than the expected duration. Pessimistic, everything will go against us. Most likely, in general events, how you can complete the activity. From that, we can calculate the expected duration using the formula TO plus 4TM plus TP by 6, as well as the standard deviation of an activity, which is represented as sigma TP minus TO by 6, or variance is nothing but sigma square, that is square of the standard deviation. You can find expected duration of the critical path by using the formula summation of expected time of all critical activities. Similarly, variance can be found out by taking variance of all critical activities summation. Now, in an example I have shown expected duration of a project is 26 weeks and the duration has a variance of 1.472 weeks. What is the probability of completing the project in 28 weeks? All of us, if you go to the probability concept, you will find that the expected time, that is 26 weeks, represented in form of mu, is having a 50% probability of being completed in that 26 weeks, the project. Here it is given what is the chance that or probability that I can complete the project in 28 days. So I use the formula for calculation of probability, and using the standard normal curve corresponding to a value of, that means the z value of 1.65, I find the probability is 0.9505, or in other words, there is 95% probability of completing the project in 28 days. What are the other type of diagrams I can have? We had seen up till now AOA, activity on arrows. Similarly, I can have activity on nodes. That means instead of events, events will be shown as activities. That means on the circles you will be representing activities. Similarly, precedence diagrams, you can show us the time from finish to start, or time from start to start, time from finish to finish, time from start to finish. So these are some of the other type of diagrams. Up till now we have seen the most widely used AOA diagram, critical path method, as well as the PERT technique. Later on in our next modules, we shall discuss further on network techniques. Thank you.